Today we're going to look at the second part of section 1.3. This section is focused on quadratic functions, and we've already looked at the basic elementary function of x squared, which is a quadratic function, the very most basic quadratic function you can have. The shape of that graph is called a parabola. So what we're seeing here with the parabola is we have this basic U-shaped graph that anytime you have a quadratic function, it's going to look like that. It might be stretched, it might be shifted, it might be reflected, but it's going to have that basic shape to it. So this section is really important because there are a lot of applications to business that originate with quadratic functions. So having a good foundation in quadratic functions is really important. Okay, so a quadratic function is anything of the form ax squared plus bx plus c. The main thing is you have to have a squared term. So anytime you have a squared term, it's going to be a quadratic function. So even if you don't have these other terms here, it's still a quadratic function. But if it's in its standard form, it's always like the x squared term first, then the x, and then the constant would be after that. So the domain of any quadratic function is all real numbers, so we don't have to worry about domain restrictions. The range is based on the vertex, and we'll look at how to find the vertex in just a minute. Okay, the x-intercept of a function is also called the zero of a function. So looking at this graph that we saw just a minute ago, your x-intercept is going to be where it touches the x-axis. So it's possible that it touches it just one time. If this graph were shifted down, then it might have two x-intercepts. And if it happened to be shifted up like this, it may have no x-intercepts. So it's possible to have either 1, 2, or 0 x-intercepts. Okay, so if you're asked to find the x-intercepts, there's really three main ways that we're going to look at. One is going to be by factoring, and we'll look at factoring kind of separate from this section. The other way is the quadratic formula, which we are going to review in this section. And then the third is using your calculator, if I can spell calculator, using your calculator to come up with an estimate for the zeros of the function. So you should have seen the quadratic formula before. Keep in mind when you're using the quadratic formula, which is this formula here, when you're plugging into it, you do not plug in the x's. It's only the constants in front of the variables that you're going to be plugging in. Okay, so if we look at this function here, this is a quadratic because we do have a squared term here, so it's a quadratic function. We're asked to find the x-intercepts and the y-intercepts. If this factored or factored easily, then factoring might be a method we would want to use on this, but it doesn't look like it's going to factor easily. So we're going to go ahead and jump in and find the x-intercept by using the quadratic formula. Okay, so for the quadratic formula, this is my A, this is my B, and this is my C. Remember to always have it in standard form before you identify the A, B, and C. So the quadratic formula tells us it's going to be negative B plus or minus the square root of B squared minus 4AC over 2A. Okay, so that would be negative 6, because B is 6, plus or minus the square root of 6 squared minus 4 times negative 3 for the A and negative 1 for the C. And then over 2 times negative 3 for the A. So we can simplify this. Okay, so this is going to be 36 minus 12. So if I do minus 12, I'm going to have 24 over negative 6. Okay, in this class, I'm not that concerned about simplifying radicals, so you can just put this in your calculator to come up with decimal equivalents. So if I said negative 6 plus the square root of 24 over negative 6, then I'm going to get, okay, Okay, it looks like 0.184. And then if I do -6 minus the square root of 24 over -6, then I'm going to get my other answer here. So I end up with two decimal answers. And because this is a business course, it is okay to leave it as a decimal and not have to simplify radicals. Okay, the other thing we're asked to find is the y-intercept. So to find the y-intercept, what we have to do is we actually have to evaluate f of 0, okay, and that's going to give me my y-intercept. So in other words, plug 0 in for the x, whatever I get out of it, that's my y-intercept. So f of 0, if I put 0 in, then that whole term goes away. If I put 0 in here, that term goes away. So I'm just left with -1. So -1 is my y-intercept, and these two values here are my x-intercepts. So if we were to look at the graph of this one, we can tell it actually has been reflected downward based on some of the reflections that we talked about earlier. And we can also see that we have two zeros of our function, so it crosses the x-axis twice. Okay, so here's one for you to practice with if you'd like to pause it and see how you do with it. Okay, on this one, if I'm going to solve this, it's not going to be factorable. So if I go and do this using the quadratic formula, I'm going to have negative b plus or minus the square root of b squared minus 4 times a times c. Okay, so on this one, we just have to then divide this by 2 times a, which in this case is 2. Okay, we'll simplify this, so we'll have 5 plus or minus the square root. The part underneath the radical here looks like if you type that in your calculator, you're going to get 65, and then that's over 4. So if you break that into the two cases, 5 plus the square root of 65 over 4, and then 5 minus the square root of 65 over 4. So we'd have 3.266 and negative 0.766. So that should be your two x-intercepts. For the y-intercept, we would evaluate it at 0. So that's going to be 2, put the 0 in, so that means that term goes away, this term goes away, and we're left with -5. So that would be our y-intercept. Okay, you see a couple questions here that all involve a quadratic function, and I'm going to go through this, but I'm going to do it on the calculator screen, so you might want to take a screenshot of this, or if you have the lecture guide printed off, it'll be there. But just have this in front of you, and then I'm going to skip over to the calculator so you can see how to put these in. Okay, on part A, we're asked to graph this, again, quadratic function. It's got the square term, so we know it's going to be a U-shaped graph. So if when you put it in your calculator, if it doesn't look like a U-shaped graph, it's because you either didn't put it in correctly, or you may need to go to press the zoom button at the top and choose number 6, which is standard. And if you do that, it's going to graph this on a window that's -10 to 10 and then -10 to 10. This is your x minimum, your x maximum, your y minimum, and your y maximum. So we generally consider that to be our standard window that we'll start each problem with. So this is a graph in the standard window. Some of the things we're going to be interested in finding are the x and y intercepts, so it may be helpful to like zoom in on those things. So looking at this, what I've done is I've gone to the window. You press window at the very top of your calculator. You can change these x minimums and x maximums. So looking at this, I can see that I have an x-intercept somewhere around -1. So I just put in -3, and then the x maximum, I just went over to 5. Okay, so it's going to show me this part here. And then for the y minimum, I went down to -8 just so I can see basically the bottom down here. And then the top didn't really matter because we weren't really interested in that part. But that gives me a window that's focused a little bit more on the characteristics that I'm needing to find. Okay, so on your calculator, there are some built-in features that I want you to use. I know a lot of you are used to just tracing and moving the cursor and writing an answer down. That is not accurate enough for this class, okay? You need to use the features on your calculator. So if I'm asked to find an x-intercept, I'm going to be finding a 0. So I need to go to, if you go to trace, and do the second function for that, it's going to bring up this screen here. That's the calculate menu, and you want to choose 0. Okay. Once you choose 0, it's going to prompt you for a left bound. So let's say we're trying to find this 0 here. Okay, so a left bound might be somewhere here. So just a number to the left of the 0 that you're trying to find. So I typed in, for a left bound, we'll put -2. Okay, so don't pay attention to the numbers that are in here because that's just something that was preset on the calculator. Okay, so then it's going to say, well, what's a right bound for it? Well, something to the right of this point here that I'm trying to estimate. So maybe 0. Okay, so let's put 0 for the x bound, for the right bound. Okay, and then your calculator says, well, what's a good guess? Okay, well, looking at this, it looks like it's close to -0.5. So let's put -0.5 as our guess. Okay, press enter. And then when you do that, the calculator comes up and it says, this is your answer. So this place here that it's crossing the x-axis is -0.765564. And that's a more accurate answer than you're ever going to be able to get by just using the trace key completely by itself. That the calculator has a built-in algorithm that lets it find these pretty accurately, so you need to take advantage of that. If we went through that same process, you have 2 zeros, so you've got a 0 here as well. So if we wanted to find the other one, we would just go back to this calculate menu, choose 0, and then it's going to say, okay, what's a left bound for it? Okay, so if this is what I'm trying to estimate, a left bound might be somewhere here, like 2. A right bound might be 4. Okay, and a guess might be 3.5. Okay, so once I put those in as answers to these prompts that come up at the bottom of the screen down here, then it's going to give me this answer here. Okay, and one thing for a 0, the y should be 0 for a true 0 of the graph, but sometimes you'll get things like this, and that's just meaning like 1 times 10 to the -12th. So that's a very, very, very tiny number, and it's just a rounding error with the calculator. For some reason, the calculator doesn't know to round that to 0, but that's okay. Don't be alarmed when you see something like that. Okay, you might also be asked to solve something like this graphically as an inequality. Okay, so same equation. We're not changing the equation. Same graph here. We just want to know when it's greater than 0. Okay, so 0 is the x-axis, and we figured out already that we have these 2 points here. So our points are -0.766 and 3.266. That's the places where it actually touches the x-axis. So the places that the graph is greater than 0 is where it's above the x-axis. Okay, so it's above here, but then for this whole part here, it's below, and then it goes up above again, above the x-axis. All right, so that means if I'm going to write this, basically all the x's back this way, the function is above the x-axis, and all the x's going this way, they're above, but the ones in between, it's below. Okay, so that means my answer would be from -infinity to negative 0.766. And also, we're going to union that with 3.266 to infinity. Okay, and just disregard that line through it. So we've got, so everything less than negative 0.766, everything greater than 3.266 would make this a true statement. If I pick a number in here, it's going to make it a false statement. So I don't want that to be part of my answer. Now, if it did say, if it was this, if it was 2x squared minus 5x minus 5 less than 0, then that's where it's below the x-axis, which would be this part down here. Okay, so for that one, it would actually be between negative 0.766 and 3.266. Okay, last example here with the calculator. Looking at this one, you're asked to solve where that same quadratic is equal to negative 3. Doing this graphically on your calculator. So you can see you would go to the y equals screen, enter the equation that you see on the left side, and then enter the negative 3 that you see on the right side. So you'll see when you graph it, so if you press graph on a standard window, you're going to see something that looks similar to this. And so basically these two things equal each other when they intersect. Okay, so they intersect here and they intersect here. It's just like an intersection on a road. The two roads come together at an intersection. So where the two graphs come together is your point of intersection. Okay, so I'm going to go back to that same second trace menu that we've used before, and I'm going to this time choose intersect. Okay. When I do that, it's going to ask me some different questions. The first one says, okay, what's the first curve that you want to intersect? As long as this equation is your first one, and honestly, if you're only doing two equations, it's always going to be that. So you can just press enter. Okay, then it says, what's the second curve? Well, as long as the second curve is what it's supposed to be, then press enter. And then finally, it's going to say, okay, what's your guess? Well, it depends on which one of the points of intersection we're going to try to find. But the easiest thing would just be to move your cursor over as close to your point of intersection as possible. And when you get it as close as possible, press enter. And it give you this as your point of intersection. So that would be 0.3507, the negative of that. And then you could, if you didn't want to move the cursor, you could actually type in like negative 0.5 as a guess. That would work as well. And then you would just repeat that same process of going to intersect, choosing your first curve, your second curve, but this time for the guess, your guess would be like 1, 2, it's like pretty close to 3 for the guess. So when you do that, you'll find that it's actually 2.851 for the other point of intersection. Okay, a little bit more information on quadratic functions. We've talked about the standard form, but there's also something called the vertex form, which is actually more beneficial for us as far as being able to graph and so forth with that. So finding the vertex can be very important. So the vertex form is this, and your vertex is actually H and K. So whatever's being subtracted here is your H, and then whatever's stuck outside here is your K. So H is basically your horizontal shift, and K is your vertical shift from the origin. Okay, a quick way to find the vertex is using this form here. Yes, it's another formula to learn, but it actually is very helpful because completing the square is our other option, and it's a several step process that you probably want to avoid if possible. So if I want to find the vertex, and the reason if I'm talking about the vertex of a parabola, that's always going to be like the maximum, or if it's upside down, it's going to be, if it's the other way, it's going to be the minimum. Those are important things to know. If you're minimizing something in business, you're maximizing, those points are important. So finding the vertex can be very important. So, so if I'm going to do that, what this tells me is that x is equal to negative b over 2a. So again, make sure it's in standard form. Look at your coefficients. Don't take the variables, just the coefficients. So it would be negative 4 over 2 times 2. So that would be a positive 4 over 4, which would be equal to 1. Okay. Then we're going to just evaluate, take that 1, plug it back into the original function. So it'll be 2 times 1 squared minus 4 times 1 plus 5. So 2 minus 4 plus 5 is going to give me, okay, just a few of the general properties. This is that vertex form that we talked about. Its graph is that of a parabola. A works just like a vertical stretch. So if it's greater than 0, it opens upward. And if it's less than 0, it's going to have been reflected, and so it's going to be opening downward. We said already the vertex is switched. Basically, you're going to switch this sign, and then you're going to leave the one outside the same. Okay. Axis of symmetry, I'm not too concerned about. You do need to know when you have a minimum or a maximum. So if you have a parabola that's opening up, you actually have a minimum. There is no maximum because it just keeps going off to infinity. But if the parabola opens down, then you have a maximum. Okay, so it all depends on what this A is here as to whether you have a minimum or a maximum. We've already talked about the domain and the range with that. Okay, and you can kind of see graphically what I was just talking about. Okay, so let's look at a few questions that you really should know when it comes to a quadratic function. Okay, so looking at this one, which direction does the quadratic function graph open? If you already know these, certainly think about what your response would be. The answer to that would be it opens up, and that I know because this is my A, so A is 2, and since that's positive, then it's going to be opening up. If it were negative, it would open down. Okay, for the vertex is where we have to do, okay, so for the vertex, we're going to do x is negative b over 2a. So that's going to be negative 5 over 2 times 2. So that will be 5 over 4. And then I'm going to plug in 5 over 4. And if you need to use your calculator, that's fine. To do that, when we plug in 5/4, it looks like we get negative 1/8. And you can just check that with your calculator. So that means my vertex is 5/4 and negative 1/8. Like I said before, I'm not too concerned about axis of symmetry, so we're going to skip that. Does it have a maximum or a minimum? Well, if it's opening up, that means it's got to have a minimum because it has a lowest point here. Okay, the question then, what is that maximum or minimum value? So it's a minimum, and the minimum value is always the y value of the vertex. Okay, so that means in this case, our minimum value is negative 1/8. So anytime you're asked to find a maximum or minimum value, you're going to go right to that vertex and you're going to give the y coordinate of it. As far as the domain goes, the domain is going to be all real numbers because it's a quadratic function. And the range, we haven't really talked about the range much, but if you think about what we're working with here, we've identified that we have a parabola that opens up and it has this vertex at 5/4 negative 1/8. Okay, so that means that it never goes below negative 1/8. And so that's going to be its range. It's going to be from negative 1/8 to infinity. Okay, on this one, I would like for you to practice on this. Again, you pause it and see if you can do that. If you want to just listen, I'm going to go through it here. So the vertex form for this one, If I'm looking for the vertex itself, which is really all I'm interested in, not so much the form, but x is going to be negative b over 2a. This is in standard form, so it's going to be negative 2 over 2 times negative 0.25. Okay, so that's going to be 2 over negative 0.5. So I'm going to end up with negative 4 as the x-coordinate of the vertex. Okay, so I plug in negative 4 to find the y-coordinate of that vertex. So just type that in your calculator. Be sure to put parentheses where it's necessary. Okay. And it looks like that gives me 6. Hopefully my math is right there. Okay, so negative 4, 6 is going to be the vertex for this particular equation here. So looking at this, we do have a negative a, so that tells me that it's opening downward, which means it has a maximum. If it's opening down, it has a maximum. And that maximum value then is 6, okay? Because that's the y-coordinate of the vertex. So the maximum value is going to be 6. So as far as the range goes, this, if I'm looking at something like this, it starts at negative infinity and it goes up to that maximum value and stops, okay? And so that's going to be the range for me. Okay, we want to look at a few business applications here. So we've got the financial department of a company that produces digital cameras found that the revenue and cost functions for X million cameras with production between 1 and 15 million cameras inclusive are given below here. Okay, so what we want to do is to find the break-even points algebraically to the nearest 1,000 cameras. Okay, so if you remember, break-even is when revenue is equal to cost. Okay, so we want to set these two things equal to each other. Right, so I'm going to have x times 94.8 minus 5x. That's going to be equal to 156 plus 19.7x. Okay, we know that we want to get rid of parentheses, so I'm going to distribute here. Okay, so looking at this, we can see that we do have a squared term. So anytime we have a squared term, it means we're working with a quadratic function, and it means we want to get it equal to 0. Okay, so we're going to pull everything over to the left side so that we can work with it better. So I'm going to subtract the 19.7x, and I'm also going to subtract the 156. Okay, so I'm going to put this in standard form, which will be negative 5x squared. If I do 94.8x minus 19.7x, that's going to give me 75.1x and then minus 156. So yes, it's getting a little bit messy. That is true. Okay, so we have the negative 5x squared comes to the front. Just combine these numbers together and get 75.1, then subtract the 156. Okay, so this is definitely not something we want to try to factor. We're just going to dive in with the quadratic formula. So the quadratic formula says negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Okay, so when you get to that point, you're going to want to just put this in your calculator and come up with your two answers. So our two answers are 2.499 and 12.530. Okay. So those are the break-even points for this particular. You could look at this algebra graphically if you wanted to and use some of the features we've talked about on the calculator today. So you could have put this in for y1 You wouldn't put this part in just the equation. Put this part for y2, and then you want to see where they're equal to each other, which means where they intersect. So you would go to the calc menu and choose intersect, and it's going to give you those same numbers that we found using the quadratic formula. Okay, so you can see these two here are exactly the same. Okay, so the last type we want to look at are working with the price demand models. So in a competitive market, the price of a product is determined by the relationship between supply and demand. So as the supply goes, we're talking about a surplus. That's when the supply exceeds the demand. So more is being produced than there's actually a need for. That's going to cause our price to come down. If there's a shortage, which means that we don't have all that we need, the demand exceeds the supply, then the price is going to go up as it becomes more valuable to have whatever product you're talking about. So the price tends to move toward an equilibrium price, which is when the supply and the demand are equal to each other. Okay. All right, so we're going to look at this problem here. So at a price of $12.59 per box of grapefruit, the supply is 595,000 boxes and the demand is 650,000 boxes. At a price of $13.19 per box, the supply is 695,000 boxes. The demand is 590,000 boxes. Assume the relationship between price and supply is linear and that the relationship between price and demand is linear. We want to find a price-supply equation of that form and then find a price-demand equation. All right, to find these equations that you're asked to find, we first need to write some ordered pairs. So the first ordered pair that I want us to write is those, since we're working first with supply, let's look at writing these as supply ordered pairs. So this one, the supply is 595,000 boxes. And so when that happens, when you have a supply of that many boxes, it causes the price to be $12.59. So we're going to do this in thousands of boxes. So 595 gives us a price of $12.59. And then the other supply, okay, all right, so the other supply is 695. So when we have 695,000 boxes, we're going to have a price of 13.19. Okay, so once we get our two ordered pairs for supply, then it's really just a matter of writing the equation of a line through 2 points, these being our 2 points. So the first thing to write the equation of a line that we've got to do is to find the slope of this line. So 13.19 minus 12.59, and this is just going back to the y2 minus y1 over x2 minus x1. So we end up with a slope when we do this calculation of 0.006. Okay, so now we're going to go to y equals mx plus b. I'm going to use either of my points. It doesn't matter which one. So 12.59, I'm just going to take the first one. 0.006, and then I'm going to put for the x the 595, and then plus the b. All right, so I'm going to get this answer here. Okay, so that's going to be 3.57 plus b. I'm going to subtract 3.57 from both sides, and that's going to give me 9.02. Okay. So this is my y, this is my y-intercept. This is my slope. So my equation is going to be P is equal to the slope, which is 0.006, times X, which is the demand, plus my y-intercept, which is 9.02. Okay, now we're going to do the same thing, except we're going to do with the demand. Okay, so if I'm looking specifically at the demand, okay, the demand is 650 for a price of $12.59, and it is, if we look at the other, it's going to be 590 is going to be for 13.19. Okay, so we want to make sure that we get everything paired up the way that we need for it to be. So we're going to calculate the slope. So we'll do y2 minus y1 over x2 minus x1, and that's a 5. And so I'll do that calculation, and I'm going to get negative 0.01 for my slope. Okay, then we'll repeat what we did before, y equals mx plus b. Choose either point, doesn't matter which one. So if I use the first one, the y is 12.59, the m is negative 0.01, the x is 650, and then we're going to add the b to that. So I have 12.59 this is going to be negative 6.5. When I add 6.5 to both sides, I'm going to get 19.09. So my equation then, going back to the form that I'm asked to give it in, is going to be P is equal to, so the price is equal to the slope times the X for the demand plus the 19.09. So that's going to be my price demand equation. This is my price supply equation. If I want to find the equilibrium point, the kind of the point where they stabilize, then I need to set these two equal to each other. So if I set my equation from part A equal to my equation from part B. So these are a bit tedious, but they are very doable if you just remember like the process. All right, so I'm going to add the 0.01 to both sides. I'm going to subtract the 9.02. Okay, so I have 0.00, actually 0.016. And then over here, I'm going to have 10.07 divide by 0.016, and that's a decimal, not a negative. And so X is going to be 629.375. That's the number of units that's going to equalize the price fluctuation there. You could also have found that on the calculator by putting this in for Y1, putting this in for Y. The financial department of a digital camera manufacturer use statistical and analytical techniques to determine the cost function. For cost, C of X is the cost in millions of dollars for manufacturing and selling X million cameras. So both X and C of X have units of millions. We want to use the revenue function that's provided and the cost function and find an equation for profit. So if you remember, profit is revenue minus the cost. Okay, so that would be our revenue function minus the cost function. Remember, when you're subtracting something, to keep it all in parentheses there and distribute it through. So here we'll have 94.8x minus 5x squared minus 156 minus 19.7. And I'm going to go ahead and put it in standard form for a quadratic. Okay, so this would be the profit equation that we're asked for. So find the value of x to the nearest 1,000 cameras that will generate the maximum profit. So looking at this, if I want to find the maximum profit, we know it's a parabola opening down. So the vertex is going to be where the maximum occurs. Okay, so basically we need to find the vertex for this equation. So I'm going to do negative b over 2a. So negative 75.1 over 2 times negative 5. And that gives me 7.51. That's the x coordinate of the vertex. And when I plug in to the profit equation, which is this equation here, when I plug in 7.51, I'm going to get 126.0005. So keep in mind these are in millions as far as our answer. The question, what's the maximum profit to the nearest $1,000? I'm not concerned about being able to translate it to thousands of dollars, but you should recognize that it's approximately 126 million is the maximum profit. Okay, so the maximum profit occurs when 7.51 million cameras are produced, and the maximum profit that you're able to generate is $126 million. Okay, for the wholesale price per camera, if we remember that the revenue is X times the price, okay, and we're also given the equation for the revenue, which is this at the beginning of this problem. Okay, then what we can see here is that the price is actually 94.8 minus 5x. We know the maximum of profit occurs when x is 7.51. So if I plug that in to this equation, that's going to give me the price that we need to sell the cameras for. So that's going to be $57 that we're going to need to sell that for. To sell the cameras for. All right, D is kind of a repeat of what we did earlier in the lesson. So you can put this in your calculator, and basically we're going to find that maximum point. So if you go to second trace, and this time choose maximum, it's going to ask you for a left bound and a right bound, and then a guess for what that maximum is. So what you're going to see is when you choose that, you're going to get 7.51, and then you're going to get 126.0005, which corresponds with what we found algebraically. Okay. And so again, that would be the maximum profit. So when you produce, so the E, for part E, you're going to say 7.51 million cameras is going to generate the maximum profit, and then we'll call it part F is going to tell us the maximum profit that we actually would make.